an expert in the testing of meters. So our next speaker is Sri Bal Mukund Vyas, Chief Scientific Officer, Yadav Measurements Private Limited. We will be talking about differences in current Indian standard IS 14439 Part 2 and the new draft Indian standard on diaphragm gas meters. So Sri Vyas has vast experience in electronic manufacturing, quality systems, laboratory management and testing. He is a qualified lead assessor for ISO 9001 and ISIEC 17025 and is an empaneled assessor for NABL. So I will request Sri Bal Mukund Vyas sir to start his talk.
Good afternoon. Are you able to listen me?
Yes, sir, you are audible.
Right. Good afternoon to everybody. And I will like to first thank BIS for inviting me to talk on this very important subject. And which I will be specifically talking about because the PGD 26 committee is at present working on revising the IS 14439 standards. These standards were made long back, so the committee is working and a draft standard has been made. So I will talk about some salient features of these draft standards and why this draft standard is required. Now, before doing that, of course, I will talk about what is expectations of different stakeholders for the gas meters and what are expectations from the standards. What is the current standards, IS 14439 in brief, and what is changing scenario and what is the context and why do we need to revise this standard IS 14439. And as I told you, we have a draft standard which has been made by PGD 26. This is under circulation, and so I will touch upon some of the important salient features with respect to the old standard, that what are the changes we are doing in IS 14439. Before doing that, just a brief introduction of my organization, Yadav Measurements. We are an NABL and UCAS accredited test and calibration laboratory. NABL, I believe most of you know, it's an apex body for accrediting test and calibration laboratory in our country. And UCAS is United Kingdom Accreditation Service. We are the only accredited laboratory by UCAS for electricity meters, gas meters, and various test facilities. And of course, we are a BIS recognized laboratory for electricity meters and gas meters, also as per Indian standards. As far as I know, to the best of my knowledge, we are the only recognized laboratory by Bureau of Indian Standards for IS 14439. And of course, we are recognized by various electricity regulators. We are based in Udaipur. Of course, we have a lot of test facilities for electricity meters, but I will not talk about those things. We have EMIMC test facilities. We have environmental test facilities. We have climatic test facilities, mechanical and all those things. But here, for the benefit of all attendees, what I would like to talk about is that we have extensive test facilities for calibration and testing of gas meters. We can test for accuracy the meters from G1.6 to G1600. I will show you some of the test facilities. We can test all type of meters as per EN 1359 2017, and all these test facilities are accredited by NABL and United Kingdom Accreditation Service, and the test certificates issued by our laboratory is acceptable not only in India but worldwide, because we have United Kingdom Accreditation Service. Like we are accredited for EN 1359, OIML, EN 14236, even the latest standard EN 17526, which is for thermal mass meter for European body. So our test certificates can be used for getting various certifications by manufacturers or by CGDs or any other stakeholders. These are some of our facilities. The test bench, what you see on the left hand side is basically a test bench up to G6, G1.6 to G6. And what you see on the right hand side is basically the primary standard for volume measurement, which is Bell prover. And we have one of the best CMCs, that is uncertainty of 0.16 to 0.2% for the Bell prover. We also have another test bench which can test the meters up to G1600. Means you can test the accuracy of the meters up to 2500 meter cube per hour with an accuracy of plus minus 0.2 to 0.3%. One of the best facility we have in India. And also I will like to add that we are the exclusive partner of Itron. Now it is known as Dresser, for repair and calibration of the gas meters in India. So with this background, I will like to go to the original subject of the gas meter standards. So I will start with what different stakeholders actually expect, because the standard should meet the expectation of all stakeholders. Be it manufacturers, be it CGDs, be it users, be it regulators, or be it consumer forums. So what people expect, what the stakeholders expect from the gas meters. So first thing is it should be reliable, robust under various stresses. A gas meter has to work continuously, unattended, 24 hours, because the gas can be used by the user anytime, 24 hours. So it should be always working 24 hours unattended, and mostly people will expect that it will work without any problem for at least 10 years. Accuracy. Today, we are using mostly class 1.5, but people will expect more accuracy. And also what we need to note is that the gas meter accuracies are not only the direct accuracies, but they are affected by temperature and the pressures. So that also has to be considered when we talk about accuracy of the meter. And another important aspect for the gas meter is it should have sustained accuracy. Means it's not that the meter, when it is tested at the time of type test or routine test or acceptance test, it is okay, but it should sustain its accuracy for 10 years, and of course it should be testable. We are into information age, and nowadays information and communication technology is very much required, and it is a focus of Ministry of Information Technology and Government of India. So the meter should facilitate easy reading and billing, should facilitate digitalization, and it should be smart. Like many of you might be knowing that in electricity meter, there is a separate standard for smart electricity meter, and in our country, there are already probably more than 5 million meters, or maybe 50 million smart meters already installed in our country. So the standard and the expectation of the stakeholder is that whatever standard which we make now should be smart, should support the smart digitalization of the industry. And the safety, of course, is the basic requirement. The gas meter has to be leak proof, it has to be fire safe, and it has to be corrosion resistance, because meters are installed in different environments. So with this background of expectations from different stakeholders, what people will expect from the standard, we are making new standards. So standard should support mass manufacturing. The standard should not prohibit manufacturing. It should support mass manufacturing. It should support mass installation. So installation should be easy. Installation should be standardized. It should be meet requirements of reliability, safety, sustained accuracy, easy reading and billing, easy installation. It should be suitable for Indian environment. Very, very important, because the India is a country where we have a wide range of climatic conditions. If we look at from Jammu Kashmir to Tamil Nadu, then we have east to west and north to south, we have different climatic environment. So, and our standard is applicable all over. And as we were talking about digitalization, and standard should be unambiguous. Many times we find that there are ambiguous requirements given in the standard. So we should try that standard is unambiguous to ensure that variability is as minimum as possible, and the interpretation should be clear. Testing and certification methods should be well defined. Acceptance criteria should be well defined. Type test and acceptance test and routine test should be part of the standard. Sorry, I don't know. Yeah. Okay. Now, just a few minutes on old standard IS 14439, which was made in 1997 or 1998. Of course, this is old standard. This was based on OIML R6 1989. Maybe at that point of time, this was the standard for the gas meter. It only covers class 1.5. The digitalization and the communication technologies, of course, they were not, at that point of time, they were not the need. So they are not covered. So no additional functionalities requirements are given. Starting flow rate is not defined in the standard at that point of time. And the temperature range defined in the old standard or the existing, in fact, this is not old standard, it is at present the valid standard, but the temperature range defined is -10 to 40 degrees centigrade. Now, what is changing scenario? As I told you, information and communication technology is required nowadays in all our aspects of life. The testing methods have changed. 1997 or 98, a lot of testing methods have changed, have improved in terms of the repeatability, improved in terms of measurement techniques, improved in terms of accuracies. So new testing methods have come up. So we need to incorporate all these new testing methods in our upcoming standard. It should support mass scale manufacturing and installations. It should meet the regulatory requirements like PNGRB or any other regulations. What industry expects? Industry expects that it would be integrated easily with information technology infrastructure, better accuracy and robustness. Like CGD wants that as accurate as possible, and the meter should be working long duration, at least 10 years, quick reading and billing, so that the finances of the CGDs are quickly recovered. At present, we are doing postpaid billing. So postpaid billing means the CGD is getting the money after supplying the gas, maybe after 2 months. So today, if I am using a gas, I will be paying after one month or 2 months or 3 months. And of course, the meter should be economic. What end user expect? End user expect that the meter should be accurate. The accounting of the gas use, which as a user I am doing in my home or in my industry, it should be visible to me how much gas I have used and maybe at different time of use, and it should be safe. Coming to the draft standard which the PGD 26 has made, I will like to make a disclaimer here once again that this is at present a draft standard, and whatever I am talking about is subject to change because a few more discussion will happen on this standard. So some of the new things might come into the standard and some of the things might change from whatever I am presenting it here. But I am sure that BIS has a process for circulating the standard before publishing it. So it will go to wide circulation and all stakeholders and all members who are today attending this presentation can view the standard and give their comments. So this standard which PGD 26 is making is based on the latest European norms EN 1359. Means guidance has been taken from EN 1359 2017, also from OIML, which is Legal Metrology International Organization, OIML R137 document. Also, for additional functionalities requirement, guidance has been taken from European norm EN 16314. And of course, I am also member of the committee who is making these standards, and lot of highly experienced people from different sectors are part of this committee, and they are giving their best to make this standard as good as possible. So I will give a brief on what are the new requirements as compared to the existing IS 14439. Is that we are adding starting flow rate, and as I have interacted with a few CGDs, they have complained that existing meters, when the people are using those meters at very low flow rate, they are actually not recording the volume. Means the consumer is using the gas, but meter is not recording the volume. So starting flow rate should be required. Once you define the starting flow rate, then these meters, the design will be required to measure some minimum flow rate. So that is what is one of the requirement we are adding. We are adding influences of other devices, like as I told that the meter will have lot of additional functionalities, how it can influence the performance of the meter. Resistance to high ambient temperature, because sometimes there can be a fire in the building, in home. Even in that case, the meter should not leak, it should not aid to the fire. So that is the requirement. Resistance to heat, a high ambient temperature, it is proposed to aid. Standard have very good mechanical performance test. Better mechanical performance requirements are added. Better metrological test requirements are added. In fact, we are adding class 1 also instead of class 1.5. So there will be an option of class 1 and class 1.5 both. The CGD or the users can select as per their need. Electromagnetic compatibility test, we are referring to the latest standards. Similarly, the climatic standards, we are referring to the latest standards, and we are extending the ambient temperature requirements for the gas meter from -10 to 40 to -10 to 55 degrees centigrade, which we believe that will meet the requirements for our whole country. That is why we are increasing this range. In addition to that, we are adding that the requirement that the meter should work efficiently and correctly with a gas temperature of -5 to 40 degrees centigrade. So we are adding this also, that the gas temperature also should not influence the performance of the meter. And of course, corrosion is very, very important for the gas meter, because corrosion can make the meter unsafe. So there are lots of corrosion resistance requirements we are adding. And also we are adding overload flow withstand capability. Sometimes if the meter is faced with a flow rate more than Qmax, then also the meter should not get damaged, and it should work correctly when the flow rate is normal. So coming to the corrosion resistance requirement, we are adding the requirement scratch resistance of the protective coating, the adhesion of the protective coating, how strong is the adhesion of the protective coating, impact resistance of the protective coating, chemical resistance of the protective coating, resistance to salt spray, and resistance to humidity, and resistance to storage temperature. So all these tests, all these requirements, it is proposed to add in the standard, so that the meter has very good internal and external resistance to corrosion. As far as mechanical requirement is concerned, we are adding robustness of the meter case, which is very important. Meter case should be very safe. There should not be any leak. So external leak tightness test, resistance to internal pressure, and sealing requirements. Also, the connections are being, there are requirements related to the connections, because sometimes there can be a leak from the connections. So connections, test for the connections are also being added, in terms of thread strength, in terms of torque, in terms of bending moment, and of course resistance to vibration, resistance to impact, and resistance to mishandling, which is basically a drop test. As I told earlier, we are adding a requirement which is named as additional functionality requirement, and this additional functionality requirements will actually support the integration with the digitalization and make it smart. So there are three types of additional functionalities defined, which is called AFD1, AFD2, and AFD3. As you can see, AFD1 is basically the additional functionalities which are integrated part of the gas meters. AFD2 is additional functionalities which are attached to the gas meters, and they can be removed, but they are they are integrated along with the gas meter, but they can be separately identified. And AFD3 is type of additional functionalities where there are two different blocks, two different identity of the additional functionalities. And these additional functionalities requirements will support prepayment functions, which will be very useful for the consumer also, and for the CGD also. It will support software security and the firmware upgrades. If this is a smart gas meters, it will support tariff management and battery management. And also it requires specific, because prepayment function will require a sort of valve. So this valve can be shut off and shut on depending on the payment is pending from the consumer or not. So the valve performance becomes very, very important. So this is about additional functionalities. And of course, a lot of new test methods, improved test methods, because as I told, sustained performance is required. So we are adding tests related to aging, related to environment. So meter will be required to work continuously at high temperatures. Meters durability test, that if continuously there is a flow and the flow rate is changing, whether the performance of the meter is getting affected. Salt spray test. Metrologically, we are adding weighted mean of error for the full range to ensure that the meter's accuracy is controlled not only at a particular flow rate, but for the full range. We are trying to ensure that the tolerances and acceptance criteria are well defined, and of course there are many more improvements compared to the IS 14439 1997. So this is about this and what we expect actually from all of you, those who are members of PGD 26 and those who are not member of PGD 26. We want that you all go through this draft standard, which I'm sure will be circulated by the Bureau of Indian Standard, and provide all the comments. On behalf of BIS, I will like to mention that all your comments will be duly deliberated by the committee and considered for the improvement of the standard. What we want is the standard which we are making is one of the best in the world, and our standard published by Bureau of Indian Standard is not only used in our country but is used by other countries, which will enable not only make in India but enable export by the Indian manufacturers. So thank you very much, and I'm sure we will be able to publish a very good standard. Thank you.
Thank you very much, sir. You have very beautifully summed up the changes that we are incorporating in the new version of the current standard. You have explained the expectations, excuse me. You have explained the expectations of the stakeholders from BIS as well as the expectations of BIS from the stakeholders. So, what I wanted to tell all the stakeholders you have already included in your slide. So thank you very much for that. And surely we will be able to reduce the shortcomings of the previous standard and publish a much better standard. So with that, I thank you for your presentation, and let's see